Okay, go ahead.
Just share. Everyone can see?
Yes.
So hello everyone, I'm Yousef Tannous. I recently joined the organization. I'm here to present this explorative work on preparing data for parallel trees. So this work aims to sample a subset of aligned sentences from parallel Hebrew-Arabic corpora. Sampling this subset, we had two goals in mind. The first one is to select documents with the highest number of aligned sentences. And the second one was to select the most lexically diverse documents to ensure a maximal representation of lexical items. Sorry. So by bilingual parallel corpora, we mean a text that is available in two languages. We had the original text of Hebrew and its translation in Arabic. It's the all rights dataset, which is a dataset that contains articles that are written in Arabic, Hebrew, and English about rights and entitlements. So parallel corpus is a valuable source of a kind of linguistic meta-knowledge, which serves a variety of applications, such as tokenization, named entity recognition, and syntactic parsing, and morphology. So this is the pipeline of this work. So remember, we have two goals in mind. The first is to select the highest number of aligned sentences, and the second is to select the most lexically diverse documents. Towards the first step, which is to identify these parallel corpora, parallel texts. So we identify these parallel texts using tricks and anchors that requires no linguistic knowledge, such as hyperlinks for the parallel articles, timestamps, authors, and etc. So after identifying these candidates, we can compare them also by using a fairly simplistic approach, maybe by comparing the markup of the HTML markup or wiki markup, and we can use a more sophisticated techniques that I will present in a moment. So the second step is to align the parallel texts on the sentence level, associating sentences that translate each other. As you can see here, these two paragraphs translate each other, and you can see the different segments of this paragraph that are associated on the sentence level. So there's a couple of ways to do so. We chose to look into the Gill and Church algorithm, which is one of the classical algorithms for unsupervised sentence alignment. It's a simple and language-independent algorithm based on a statistical model of character length cast in a dynamic programming framework. So their motivation behind using dynamic programming was really interesting. It was because it was widely used in sequence alignment problems, which is a way of arranging the sequences of DNA to identify regions of similarities. So you should expect these matching techniques to be useful, as long as the order of the sentences does not differ too radically between the two languages. And it's a fairly relatively fast algorithm as opposed to other algorithms that require heavy computations. So the algorithm considers a matrix with all the partial solutions, and then it takes the most optimal solution according to a probabilistic score assigned to each proposed pair of sentences. And this probabilistic score is calculated by using this variable, which is namely the distance measure. The distance measure is based on the assumption that each character in one language gives rise to a random number of characters in the other language. So if you can look at this equation here, the mean, which is the C, is the expected number of characters in L2 per character in L1, and the variance is the number of characters in L2 per character in L1. if we say that L2 is the Arabic language and L1 is the Hebrew language, calculating the mean on our data, we have found that that the mean is always greater than 1, which could mean that there are generally more characters per sentence in the Arabic language as opposed to the Hebrew. Another hypothesis is that translators tend to take implicit meanings and make them more explicit while translating. So they will use more words to express. Yeah. So evaluation is an essential part of the parallel sampling process. Since we want to identify a subset with the least amount of alignment error, we want to evaluate how accurate the alignment error is. So this is an output. This is an output of the alignment algorithm, and you can see just by eyeballing that the structure and sentence lengths are fairly similar. But we want a more reasonable estimation of the error rate of the alignment output. If you look here also, you can see just by eyeballing that the structures are similar, but there's an alignment error, which is these two sentences that do not translate each other. As you can see, they are structurally similar, but with a minimum amount of lexical knowledge, you can say that they are not translations. So we incorporated a word overlap variable, which is the number of overlapping words in each proposed pairs of sentences, and incorporated this measure into the conditional probability used for the evaluation. So if you can see that these al-marad, hamakhala, they are exact translations, net, al-iba, ala, khayim. Yeah. So we want to maximize the conditional probability of matching sentences given the distance measured between these two sentences and the word overlap score. So we apply logistic regression to estimate the error of the predicted alignments. The word overlap variable generally elevated the accuracy of error prediction. This is a less formal way to show it, but yeah. So yeah, we are here, but we are still stuck with a lot of sentences. So we need a quantitative technique to look for the most lexically diverse documents. So we use topic modeling to do that. Topic modeling is an unsupervised machine learning technique to determine cluster words for a collection of documents. So it basically extracts abstract topics from these collections. LDA is the topic model we use to classify documents into topics. The motivation is that we can augment each article with a score that expresses the lexical diversity of the text with respect to the other articles. This is a graphical representation of the abstract topics extracted from the all rights data that we worked on. Topics are represented by the occurring words in each topic and their corresponding weights. We can see here the intersection of different topics, which would indicate how diverse each of the topics is. So executing the model on a single document gives us the different topics and a score for each case that represents the weights of the topic. We use these weights and the diversity of each predicted abstract topic to evaluate the lexical variety of the whole document. Then we attach this score to each article, thus representing each article's lexical diversity. We then extract the highest scoring articles from the top aligned documents according to this measure. Hope it's clear. And yeah, so I think, yeah, so we got to the end of the pipeline. It was fairly fast. So we sampled well-aligned trees and at the same time tried to keep maximal vocabulary coverage. So that's it's a little joke. And thank you.
Thank you so much, Yousef. Okay, so this is part of our work in progress on curating large data sets that we have and turning them into something useful for unsupervised learning, as well as for supervised. So we are going to annotate 700 parallel trees between Arabic and Hebrew, and there are very nice stuff you can do with that. I'm not sure if you have questions, but I suggest we give Nick the floor again, and he'll finish his talk. And then if anyone has questions to any of us, you're very welcome. So Nick, if you're still there.
I am. I'm back even.
Okay, you're back. Okay.
So sorry about that.
Sure.
It turns out that I guess it's 10-year-old Mac is maybe not the most friendly to Zoom. Let me get back to my talk here. Okay, everybody can see my screen?
Yes.
Okay. So I was talking about this internal QA.py script that one of our annotators wrote and was run manually at QA time after a sufficient number of trees had been annotated from each batch. We wanted something that could be run automatically and that reported its errors in some way that was machine readable. And so we turned to the official Universal Dependencies Validator. Sorry, I'm sure I'm repeating a little bit, but I'm not sure at what point my computer crashed. I think I kept talking into the void for a bit.
Yeah, that's
so, sorry?
That's okay. We saw the slide, yeah.
You saw the slide. Okay, so I'll just very quickly repeat what I said before, summarize that. So this is a script that's used for the official releases from Universal Dependencies Project. It has 5 levels of validation. So the first one is just that the syntax is essentially correct in the conlu file. At level 2, it checks that you actually have annotations for trees, that you are using the universal part of speech tags and relations. At level 3, it checks that you're following the Universal Dependencies language independent guidelines. So Universal Dependencies on their website has a fairly large collection of guidelines for how it's meant to be used, both language specific and language independent. So level 3 is just checking the language independent guidelines. So I guess sometime in November, even before that, maybe in October, we were up to level 3 conformance. So annotators were not able to save any trees that had errors in levels 1 through 3. And this was a source of great frustration because, of course, the arburator tools themselves are generating trees with mistakes there sometimes. So we fixed a bunch of bugs because of that. Next, over a period of about a month and a half, I converted with the help of Hila, I converted the language specific, our personal IAHLT guidelines into language specific data for the UD validator. So at level 4, we're checking that the features, tokenization, and dependency relations are consistent with our guidelines. And then level 5 is checking that we have that all of our that we are correctly labeling auxiliaries and copulas. Once our entire tree bank passes this, in principle, we would be considered ready for an official UD release. I see a chat message. Oh, that's for you. So we incrementally introduced these various levels into the arburator annotation experience, and with the help of annotators, help and anguished cries, of annotators. We rewrote the language-specific data files for Hebrew. They were inherited from the Goldberg Tzfarti tree bank. Yeah, I really feel for the annotators. I got several tortured emails during that process, and we developed a better communication after that, I hope. And I grew much more cautious. But it's still not enough. If you took a look at those levels, nowhere did it say anything about any real relationship between features and parts of speech, or how relations interact with parts of speech. A very small portion of our guidelines can be expressed in terms of the official Universal Dependencies Validator, and the goal is to catch all of the guidelines, any violation of the guidelines, using machine readable rules. And the UD validator is not sophisticated enough for that. It's not what we are able to catch using the UD validator is not really sufficient to significantly reduce our quality assurance workload, and that's our real goal, is to reduce the QA workload so that we get increased throughput. The idea that I had was GRU is a very sophisticated tree searching and transformation mechanism. It has an entire research group dedicated to it in INRIA in France. Instead of usually the way that GRU is used is you have a large corpus and you're looking to find out if some particular construction or some particular pattern occurs in this corpus, because you're interested in doing corpus linguistics. You're interested in doing some statistical analysis of some large corpus, which has already been tree banked. My idea was we can use GRU to search for bad trees instead of interesting ones. I designed the GRU validator, which is called Groovy. It takes a library of GRU patterns which identify deviant trees which are violating some guideline. And my goal is to slowly convert the entire guidelines over to Groovy rules. So here's an example of a Groovy rule. It contains in a comment. It contains an error message that is shown to annotators if they make this mistake. So here it says add position, and then it gives a reference to the node. Can take accusative case only as the dependent of an object conjunction, noun modifier, or orphan head. So this is telling you something about this when a node with this part of speech, a token with this part of speech, can have this feature, and it's related to the syntactic structure of the sentence. This is something that could not be expressed using the Universal Dependencies validation official validation script. And here you see the code that you write in GRU's searching language. So it's looking for a node which it calls X, with part of speech add position and case accusative. And then it's filtering out the ones that it finds if it can find a parent in the tree, actually a grandparent. So you see this, here we have Y to Z, Z to X. So X is the thing we're searching for, Z is a parent of it, and it doesn't matter what Z is, and Y is the parent of that and has to have, and the relation between Y and Z must be one of these four. And originally, I believe we had only object there. And so through lots of tortured discussion with Hila, we're gradually working this from something that's not literally correct in the guidelines, but that all of our annotators are capable of extrapolating into something which is sufficiently spelled out carefully for a machine. So this formalization of our guidelines is also very useful. So our validation processes now are to have validation at all stages. So at the annotation time, we're gradually incorporating and ratcheting up the aggressiveness of our validation for the annotators. At release time, so we're running through automated and manual quality assurance at release, and we're running all of these scripts to find any possible inconsistencies or deviations from the guidelines. We're also using it now for guideline revision. So as we explore the sorts of things that are caught by tentative rules, our annotators are finding new ways to extend the guidelines and coming up with new rules. And when we are thinking about changing the guidelines, we can implement this as one of these groovy rules and see what the effect will be, how much work we'll have to do revising our tree bank, the trees that we've already annotated and released. These validation hooks are preventing contribution of guideline violating trees. And it sort of turns our guidelines into which is already a living document, because we keep making changes to it, but also it enables us to have constant review of that document. So as our annotators are working, we're with updated guidelines, we're incorporating these rules into the CI system, and we're getting feedback on how conformant our tree bank is as we update the guidelines. This continuous integration system is giving us constant feedback on our tree bank, and it's helping us to evaluate how much work proposed changes could be. So let me talk about the future now. So our immediate goals are universal adherence to the guidelines. So that will involve some revision of our tree bank, but also it will involve some revision of the guidelines. So those two documents are slowly evolving to be consistent with each other. And this will reduce the variation in our annotation to only things that are ambiguous according to the guidelines. So once all the guidelines are formalized and the entire tree bank is passing all of the guidelines, then any inconsistencies in annotation will only be because the guidelines are ambiguous. And this is going to reduce the uncertainty in models in the language models that we're training to places where we're data poor or guideline ambiguous. So once we have that, we can use that uncertainty in order to identify weak points. So maybe the places where our model makes non-confident or tentative suggestions, that's either a suggestion to us that we need to extend or revise our guidelines because the model has seen multiple ways to do something, and it's not sure which it should choose, or it could be an indication that the model hasn't seen enough of this, and we need to find more sources that exhibit this phenomenon so that the model can grow more confident. So that's how we use uncertainty. We can also use certainty to help our annotators and those writing our guidelines. So if we find uncertainty in the machine annotation, then that's something that should be pointed out to the annotator, that the model is less sure of this, and that's a place for special attention. Conversely, if the model is extremely certain of something and then the annotator contradicts it, this might be a sign that we should revisit the guidelines, or that the annotator should double check that they're following the guidelines. So that's all that I have.
Thank you so much, Nick.
Yeah, I'm happy to take questions.
Okay.
Maybe you can stop sharing the screen and you can see each other.
Oh, yep.
Yeah. Okay. So there was one question by Yuval posted to Yousef, and he answered it. Anyone want to ask any question?
To all the shy people, you can email us the questions and we can come back to you.
It's more for all the tired people, I believe. So yeah, like self-company included. So yeah, I suggest anyone who wants to know more about the organization can contact Avner, either if you need the data for research or if you want to use it commercially and you're not a member. So I'm not sure what it means, but Avner surely does. And I will update our GitHub and I will post it somewhere. Somewhere can be on the, I don't know if the Meetup has any kind of communication channel where I can send her an update.
Yes, we have it. You can share it on our
So
group.
I'll go follow up on the request for the document level representation of the old tree bank. So we are also in the process of trying to release 5,000 sentences as complete open source. Also maybe as a bait for new members, and also for the sake of giving back to some open source communities that helped us. So that's also pending. It depends on the decision the consortium takes. So you can follow up on that too.
Yeah, and I would like to thank again all the people that stay so late and hearing our achievement and innovations, and we'll be very happy to get any feedbacks, questions, comments, and keep in touch. It can be via Shani with the community or directly to our email, as you wish. So thank you very much. And
thank you so much.
Until we'll update you next time about the next achievements and innovations.
Thank you.
Awesome. Thank you. Have a good night, everybody.
Thank you, everyone.
Good night to most of us. And
Yeah.
Amir and Nick are still awake. Yeah. Bye-bye.
Bye.
Bye. Thank you.
Avner?
Yeah.
Quick question. Do you know the 5,000? Sorry, I hear myself.
There's some echo again. Yeah.
Do you know what is the topic of the 5,000 annotated sentences that you might publish soon?
No, you're talking about the already 15,000.
I don't know, it said 5, but 15. Okay, yeah.
No,
do you know
about the Hebrew?
Hebrew, yeah, the Hebrew one.
Most of it
it's Wikipedia.
From the news and from Wikipedia.
It's Wikipedia
news related topics.
It's news or Wikipedia?
News.
The 5,000 that we might release. Yeah, the 5,000 that we might release are going to be Wikipedia, basically.
Cool.
You talk about the public, not the members. The public one.
Yeah.
Yeah. Okay.
And the one that you might release is it's morphological or like or also NER. Like I'm just like which level of annotation did you do already?
Yeah. We have 3.
I saw the plan. Yeah.
Yeah, we have 3 types of annotations: the morphology, dependencies, and NER. So those are the 3 types.
Cool. Thank you very much. Can I reach, like, who is the best PM person to reach? To you, to Carl, or to?
Where do you work? You work in a company or independent?
No, I also work in a company, but I'm also a student of Howell Sarfati. I'm working on the core. I'm actually now working on a core reference corpus, and this is my thesis. And I'm currently working on the Hebrew theory bank, but I want to add more data.
Okay.
And a lot of my work that I'm doing now is in order to tag more data. And actually, I'm working on, like, I even did an algorithm that know how to take stuff like NP chunks that doesn't really matter out of tree banks, like the UD schemes specifically, the Hebrew one.
Okay.
Anyway,
So,
I would really be happy to have longer stuff.
Okay, send us an email to the info@ihlt.org. Okay, with your contact details, and we set a Zoom with you and discuss everything.
Cool, thanks, great. Thank you on the talk, everyone.
Sure.
Ciao.
Okay.
Thank you very much.
Anyone else? Take the opportunity. Bye, Kfir and Carl.
Bye, bye.
Boston.
Bye bye.
Thanks for the
Take
great
care.
talk.
Take care.
Goodbye. Thank you very much.
Bye.